Hello everyone, how are you? I hope you guys in good condition. So let me introduce myself. My name is Sabrina Nur Maulida. I am a student of Mathematics Education UNES. In this video, I want to tell you how to solve the problem related to proving and conclusion technique. So without much ado, let's look at the explanation. Okay, the first problem is proof by induction. A number given its decimal representation is divisible by 3 if and only if the sum of its digits is divisible by 3. Okay, the solution is let us prove this by induction on number of digits n. N is equal to 1. Clearly, then a number is divisible by 3 even only if the sum of the digits is divisible by 3. For example, the number 369 satisfy this case. So the hypothesis is assume that the statement holds for n equals to k and k greater equals to 1. A number composed of k digits is divisible by 3 even only if the sum of its digits is divisible by 3. Okay, I know this step looks confusing, but I'll try to explain. Let n equals k greater equals than 1 from the hypothesis. Let x be a number composed of k plus 1 digits. Our claim is to prove that x is divisible by 3 even only if the sum of the digits and in x is divisible by 3. Let the decimal expansion of x equals ak minus 1 until a0 bx equals ak times 10 power k plus ak minus 1 power times 10 power k minus 1 until plus a0 times 10 power 0 p the equation 1. And since am times 10 power m can be written as am times am times 10 power m minus 1 like this, equation 1 can be written like this. And since 3 divides 10 power n minus 1 implies that 3 divides this, by the hypothesis ak plus ak minus 1 plus until a0 is divisible by 3 even only if ak minus 1 until a0. Thus, x is divisible by 3 even only if ak is divisible by 3. In other way, x is divisible by 3 even only if ak plus ak minus 1 until plus a0 is divisible by 3. Therefore, x divisible by 3 if and only if the sum of the digits in x is divisible by 3. Now, the second problem, show that any integer composed of 3 power n identical digits is divisible by 3 power n. For example, 222 is divisible by 3 and 555,555,555 is divided by 9. To solve this problem, we prove this by induction on n. For n equals to 1, we know that any 3-digit integer with 3 identical digits is divisible by 3. Since for any k element 1 until 9, k equals to k. Further, 111 is divisible by 3. Therefore, k is divisible by 3. So the hypothesis is assume that the statement is true for n equals to k and k greater than equals to 1. Okay, for the next step, for n equals to k greater than equals to 1, let x be an integer composed of 3 power k plus 1 identical digits. We know that x can be written as x equals to y times z, where y is an integer composed by 3 power k identical digits and z equals to this. 10 power 2 times 3 power k plus 10 power k 3 power k plus 1. For example, x equals to 666,666,666 is equal to 666 times 1,001,001 equals to y times 10 power 2 times 3 power k plus 10 power 3 power k plus 1. Y is divisible by 3 power k by the hypothesis and z is divisible by 3. Sum of the digits is divisible by 3. Thus, x is divisible by 3 power k plus 1. So this is the last question and related to the conclusion. Find the negation of it is raining and the sun is not out. We have 3 steps to solve the question. So first, write the statement in symbols. Let P be it is raining and let negation R be the sun is not out. We are to negate P and negation R. The second step is use the proper equivalence to negate the given statement. We are to negate the conjunction P and negation R. So negation from P and negation R is negation P or R. Right? And the last step is write the results in words. Negation P or R means it is not raining or the sun is out. Okay guys, I think that's all from me. I know there is a lot of mistakes, so I'm so sorry. If you have questions, you can email me on snmririn@gmail.com. So thank you for your attention. Bye.